Hello, hello. All right, okay, so let's start the lecture today, okay? So if you have any question, okay, so please type in the chat window, okay? All right, okay, so after the lecture, okay, so I have the office hour, okay, from 4 to 5, okay? So if you have any question, okay, so please keep your Zoom open, okay? And for example, if you have any question about kind of the lab report, okay, or some other assignment, okay. All right, so today we'll start a new chapter, chapter 20, okay? So the title of the chapter 20 is kind of enolates and also other carbon nucleophile, okay? So for this chapter, okay, so we skip two sections, okay? The first one is kind of the 27, okay, carbon as a living group, okay? Right, living group, okay, this, okay. And the second one kind of 29, okay, so that's the other carbon nucleophile, okay. All right. So these two sections, okay, so pretty much last important, okay, so we won't kind of the top box kind of during the lecture, okay. So you don't need to study these two sections, okay. Yeah. All right. Okay, so for this chapter, okay, the title kind of Enol and also other carbon nucleophile, okay, so pretty much it's the top kind of the alpha carbon, okay, as a nucleophile do all kinds of reactions, okay. So here's kind of what's going on, okay, still a little bit kind of the clarification, okay, so so the alpha carbon refers to kind of carbon next to carbonyl group, okay. So this is alpha carbon, beta carbon, and gamma carbon, okay. So this chapter 20 all talk about kind of the chapter the 18 is kind of carbonyl, 19 also carbonyl, okay, and then chapter 20 also about carbonyl, okay. But it's talk about kind of this guy, okay, alpha carbon, okay. So this one adds nucleophile, okay, to do all kinds of reactions, okay. Right. Right. And I don't know whether you guys remember, okay, so in the instruction kind of the lecture, okay, so I bring up kind of this schedule, okay. I said kind of the for chapter, for organic chemistry 2, okay, so the difficult for all the chapter kind of average out, okay, so not too easy, also not too hard, okay, but only one chapter stand out, okay, so that's this chapter, okay, chapter 20, okay. So this chapter actually kind of doesn't cover too many reactions, okay, probably totally only 6 or 7 reactions, okay, but much more complicated mechanism, okay, much more complicated mechanism, okay, and easy to lose, okay, and easy get confused, okay. So I will try to slow down in these chapters, okay, and then we will study kind of this chapter for 2 weeks, okay. And during these 2 weeks, okay, so especially during the lecture, okay, so I will give out a lot of practice, okay, so the practice kind of a better way to learn this chapter, okay. So make sure you work on the question, okay, during the kind of lecture, okay. And also in this chapter, okay, so when I give kind of the notes, okay, so I will use kind of the colored pen, okay. Yeah. So if you have some kind of colored pen, okay, so you can take it out, okay, so try to draw the same colors, okay, so that's easy to figure out kind of what's going on, okay. Otherwise, sometimes kind of the final hand be decide, okay, so the final exam, okay, so original kind of I want to put on the November 30th, okay, so on Monday, but the school sent the notice, okay, so all the class include kind of final has to be finished during the Thanksgiving week, okay. So very likely, okay, I will put the final exam on Sunday or Saturday, okay, so we can decide kind of later, okay, so Sunday or Saturday of the Thanksgiving week, okay. Right, okay, we come back to kind of the chapter 20, okay. So as I mentioned, okay, chapter 20 is kind of a pretty hard chapter, okay. So I want you guys a little bit of focus on, okay, okay. And we'll do a lot of practice, okay. So hopefully, okay. So you guys can get a better result, okay, from the chapter 20, okay. So in the previous year, okay, so exam 3, okay. So the exam 3, okay, so cover chapter 20, okay. So the average grade kind of exam 3 is kind of around like 55 to 58, okay. The reason for that is this chapter, okay, the chapter 20, okay. So this is a very hard chapter, okay. Sunday after Thanksgiving, okay. Sunday after Thanksgiving, okay. Yeah, so I will talk about more about the final, okay. So probably close end of this semester, okay. Yeah. All right, okay. So I want you guys still focus on kind of chapter 20, okay. So don't think about too much about the final exam, okay. So because chapter 20 kind of the pretty tough chapter, okay. All right, okay, and so the chapter 20 all about kind of Enol or Enolate kind of the nucleophile, okay. So we already talked about kind of Enol and also the keto tautomerization, okay. So that's how do we generate Enol, okay. So right, so at that time, okay, so I remember kind of probably additional to the water to the CC tribond archive, okay, so we talk kind of, I said kind of we will learn mechanism for the Enol keto tautomerization, okay, later, okay. So that's here, okay, because this chapter all about kind of Enol and Enolate, okay. Tautomerization. Right. So the mechanism for the Enol, the keto tautomerization can happen at kind of either acid condition or kind of basic condition, okay. Right. So under acid conditions, okay, so pretty much what happened kind of so this is the Enol, okay. Right. So the lone pair electrons on oxygen, okay, come down, okay, and then the shared electron between the alpha carbon and also carbonyl carbon, okay, pick up one protons, okay. And then falling kind of this proton pick up by some kind of base, okay. So normally weak base, okay. So like water, okay. Yeah, that's give you kind of final ketone, okay. So the acid condition, okay, so involve kind of Enol, okay. But in the basic conditions, okay, so keto tautomerization kind of involves basic actually called kind of enolate, okay. Right. So this time, okay, so instead of kind of the lone pair electrons on oxygen come back, okay, so hydrogen, okay. Right. So that's still start with Enol, okay. It's kind of the enolate, okay. So generate now first, okay. So on the basic condition, first kind of some strong base come in, okay. Pick up this the Enol kind of protons, okay. Right. And then lone pair electrons on oxygen come back, okay. Right. Okay, so this two species, okay, this one and also this one kind of actually both are kind of the enolate, okay. So just kind of resonance structure of enolate, okay. Okay. And eventually, okay, so this enolate can pick up the protons from kind of HB, okay, so some base pick up one hydrogen, okay, so now can give back the hydrogen, okay. Right, give it kind of the final kind of ketone, okay. So that's a ketone. Okay. Yeah, for this chapter case, most reaction case so involve this kind of mechanism case. So the acid condition or basic condition, most kind of pretty much based on the basic condition case. So instead of the enolate can pick up kind of proton case. So enolate will act kind of nucleophile okay, here, this guy okay, and then attack something case. So that's happen the reaction okay, and that show down the screen okay. So the alpha carbon okay, so that's as a nucleophile okay, and then attack okay, as a kind of some kind of electron file put on here okay. And so why the alpha carbon can add nucleophile because the acidity of the hydrogens okay, so of alpha carbon okay, so the two effect okay, so first kind of inductive effect okay, because there's kind of the electron withdrawing group okay, so carbonyl okay, next to it okay, can have to hold negative charge okay. Second, the resonance effect okay, so if there kind of that's showed here okay, so these lone pair electrons can push back give to kind of oxygen okay, so you have kind of the two resonance okay, have to look like kind of this negative charge okay, so that's why kind of a little bit of acidity. So the pK for the alpha carbon is around like 19 to 20 okay, so that's enough. You apply some kind of strong base okay, enough to depronate kind of the alpha carbon okay, and then carry the reactions okay. Okay, so as long as you can find a base, okay, so it's conjugated acid, okay, so pK higher than kind of the 20, okay, so that you can use kind of the depronated kind of alpha hydrogens, okay, and so here are some kind of common kind of base, okay, so using kind of the depronated alpha carbon alpha hydrogens, okay. So sodium amide case, so that's we already learned it many times. Okay, so pK kind of 38, okay, pretty strong kind of base. Okay, and then another two base kind of probably new for you guys. Okay, one is kind of LDA, okay, lithium diisopropyl kind of amide. Okay, so this one okay, so probably in chapter 9. Okay, so I talk kind of the list the chart. Okay, so how to determine kind of SN1, SN2, E1, E2 reactions. Okay. And one group of the nucleophile and base is called kind of strong nucleophile, but strong base but weak nucleophile, strong base weak nucleophile. Okay, like here the sodium terebutyl okay, and then another one kind of LDA. Okay, so that's I said kind of we will talk about kind of LDA in future class. Okay, so that's here. Okay, so lithium kind of just counter ion. Okay. So this one kind of the pretty bulky kind of substitute group, brown kind of around kind of the nitrogen okay. So only work as kind of the strong base okay. But weak nucleophile okay. Yeah. So that means kind of if you see this one okay, so pretty much just kind of play as base okay. So you for example kind of use that kind of in the E2 reactions okay. And next one kind of sodium hydride, okay, sodium hydride kind of very strong base, okay. Occasionally can be used as kind of the nucleophile, okay, so hydride addition, okay, right. And those strong base can be used kind of the depronated ketone, ester, and also nitrile, okay. So the maybe show you guys here. Right, so this is the ketone, okay, and you can depronate kind of this alpha carbon, okay, alpha hydrogens, okay, and then convert to kind of enolate, okay. And then same thing for the kind of ester, okay. Yeah, dipronate kind of is alpha hydrogens, okay. Nitrite kind of quite unique, okay. So there's kind of no carbonyl, okay, but the same tribond has the similar property as kind of carbonyl, okay. So in this case, yeah, if you have kind of the alpha hydrogen next kind of the nitrile group, okay, so you can also depronate it connected by this kind of strong base, okay. Yeah, LDA, okay, keep in mind strong base, okay. Don't mess up with kind of lithium aluminum hydride or kind of the other lithium reagent, okay. So this one only as use base, okay. Other use kind of either nucleophile or maybe some kind of the reduction reagent, okay. All right, okay. So that's kind of the common kind of the carbonyl or kind of the compound, okay. So if you further increase the carbonyl the numbers, okay, by the alpha carbon, okay, so you can further increase acidity of the alpha hydrogens, okay. So here's kind of the example, okay. So instead of kind of only one carbonyl, okay, so you can have kind of two carbonyl, okay, next to kind of alpha carbons, okay, and then this hydrogen become kind of pretty acidic, okay. So like this here, the 2,4 the pentene dione, okay, so it's kind of the dione, okay, and then this kind of the beta carbonyl kind of ester, okay, so that's kind of SO, acetyl acid, okay, and also last one kind of diester, okay, has kind of two ester connected with kind of center the carbon alpha carbons, okay. So yeah, you can see kind of pK kind of become kind of 9 until like 13, okay. So those pK kind of the pretty low, okay. Those means kind of this hydrogen kind of easy to lose, okay. Right. Why is that? Okay, so first kind of the electron withdrawal effect, okay, inductive effect, okay. Second kind of conjugation, okay. So we have the reason for that, okay. So we have I just draw you the first one, okay. Right. So once it's lose the hydrogens, okay. Right. So you can just only one hydrogen left, okay. So you can draw kind of the resonance structures, okay. Right. So yeah, the CT double bond will conjugate the kind of CO double bond, okay. So that's make it this the enolate kind of more stable, okay. And the same thing for kind of enol, okay. So enol form is something like this, okay. So its enol form is kind of you can form kind of 6 membrane, okay, with the hydrogen bonding can help to stabilize, okay. So this is the enol form for this kind of beta dicarbonyl compound, okay. Yeah. So you can build up hydrogen bonding between this kind of terminal alcohol and also the another carbonyl group, okay. So that's make the whole thing kind of stable, okay. So remember I said kind of 6 membrane always kind of quite stable, okay. So yeah, so because kind of conjugation, okay, there's kind of double bond between these two, okay. Because of conjugation and hydrogen bond, okay, so that's making the kind of the pretty stable, okay. Right. And in this case, okay, so you don't need to use kind of strong base like LDA or kind of the sodium amide, okay. So some kind of regular base should be enough, okay, like sodium ethoxide, okay. So because kind of the ethanol pK is kind of 16, okay. So that's much higher kind of than the pK 9, 10, 9, 11, 30, okay. So that's enough deprotonated, okay. Okay, so that's the top kind of reaction species, okay. So that's enol and also enolate and also kind of acetate, okay. So like I said, kind of the pretty much this chapter, okay, so we learn the reaction all about kind of the alpha carbon as a nucleophile, okay, so to do all kinds of reaction, okay. And then can anyone tell me what kind of reaction we learned so far, okay, so involve nucleophile, okay. Yeah, please type in the chart window, okay. Right, type in chart window, okay. Any reaction we learned so far, okay, involve nucleophile. That's correct, okay. SN2. Any other? E1 is not nucleophiles kind of a base, okay? So we are base in what kind of elimination, okay? So elimination kind of E1, E2 required base, okay? But they are not nucleophile, okay? Right? So what reaction we learned in chapter 18? What's NAS? Okay, I guess the means kind of a nucleophilic acyl substitution, or right? Okay, so in chapter 18, we learned kind of nucleophilic acyl addition, okay. Right. So remember, okay, so I already have a ketone, okay, so we have some nucleophile, okay, so that's in one nucleophile. Open the CO double bond, and then it's just kind of alcohol water, okay, so like hydration water, okay. Right. So what's the reaction we learned in chapter 19? Right. So chapter 19, the reaction we call kind of nucleophilic acyl substitution, okay. Philic. Right. So pretty much I remember, okay, so yeah, we just covered the chapter 19, okay. Some nucleophile coming can replace kind of living group, okay. That's why I call kind of substitution, nucleophilic acyl substitution, okay. Right. And then another one, okay, so yeah, the probably list here, okay, so yeah, 1,4 addition, okay. Nucleophilic 1,4 addition, okay. So that's the we learned in the chapter also chapter 18. Okay, so we are just the 1,4 additions kind of we have weak nucleophile. Okay, last bulky one. Okay, we'll do 1,4 addition. Okay, right. Actually, yeah. Once you understand this, okay, so that's your life will be easier for chapter 20. Okay. So chapter 20 pretty much kind of just alpha carbon, okay, as a nucleophile do all these reactions, okay, do all these reactions, okay. So for example, okay, so alkylation actually kind of alpha carbon as the nucleophile try to do SN2 reactions, okay, react with kind of alkyl halide, okay. And then for the Aldol condensation, Aldol reaction actually kind of the alpha carbon as the nucleophile to do kind of nucleophilic carbonyl kind of addition, okay, also called kind of carbonyl nucleophilic acyl addition, okay. So that's the same thing, okay. So acyl addition, carbonyl addition, okay. And then another reaction we learned kind of called Claisen condensation, okay, actually kind of the nucleophilic kind of carbonyl substitution, okay. So that's also kind of called nucleophilic acyl substitution, okay. So this just the alpha carbon coming kind of replace some kind of living group, okay, right. And then we'll also learn one reaction called mic addition, okay. So that's actually kind of the alpha carbon coming to do kind of 1,4 addition, okay. So we conjugate kind of C double bond with kind of CO double bond, okay. So as long as kind of you keep all this in mind, okay, so that's your pretty life will be pretty much easier, okay. Another the relative new reaction kind of halogenation kind of alpha carbon, okay, and also the imine as a nucleophile, okay. Those two kind of much easier, okay, should be fine, okay, right. So theoretically speaking, okay, so we should kind of follow this order, okay, to do kind of one by one, okay. But because this week lab, okay, this week lab we will do kind of Aldol, the condensation, okay, so Aldol reactions, okay. So in this case, a little bit change the reaction order we'll learn in this chapter, okay. We'll do kind of Aldol reaction first, okay, Aldol reaction first, okay, and then go back to kind of halogenation, acylation, and acylation, and micro additions, okay. All right. So like I said, kind of this chapter, the reaction mechanism kind of quite complicated. Okay, so in this case, please try to learn all these reactions based on mechanism. Okay, understand what's going on. Okay. Right, so like I said, okay, so we'll do the Aldol reactions. Okay, so hope you guys kind of prepare kind of the lab this week. Okay, right, and then for the Aldol reaction, okay, so pretty much just okay, so. So we do the Aldol reaction first, okay. just alpha carbon as a nucleophile, okay, try to do kind of nucleophilic acyl addition, okay, to this reaction. So that's chapter 18 reaction, okay. So chapter 18, okay, remember, okay, so you have kind of aldehyde ketone, okay, so then and the nucleophile come in, okay, right, open the sealed bond, okay. And then eventually kind of this oxygen pick up one hydrogen, okay, you generate kind of alcohol, okay. Yeah, pretty much kind of this the Aldol reaction actually kind of alpha carbon, okay, as a nucleophile, okay. Right, so alpha carbon, okay. So also we can call kind of enolate, okay. Right, enolate as a nucleophile, you do kind of the nucleophilic kind of carbonyl addition, okay, also called kind of nucleophilic acyl addition, okay. Right. Okay, so here's kind of general reaction for this chapter for the Aldol reaction, okay. So for Aldol reaction, keep in mind, okay, so only happen to kind of aldehyde and ketone, okay, aldehyde ketone, okay. So these two guys kind of try to react with itself, okay. So put here. Right, aldehyde and ketone, okay. And for Aldol reactions, okay, so happen the kind of normally happen kind of two aldehyde or two ketone react with self, okay, react with self, okay, right. So like it showed here, okay, so you have kind of two the ethanol, okay, react with self, okay, gas reaction, okay, right. So here I show you guys kind of general reaction, okay. So right. So that's maybe aldehyde or ketone, okay, right. And then another kind of the aldehyde ketone coming, okay, contribute the alpha carbon, okay. Right. So the blue one contribute kind of carbonyl carbon, okay, and then another aldehyde ketone contribute kind of alpha carbon, okay. So you build a bond between these two guys, okay. And the reagent used for this reaction, most time kind of sodium hydroxide, okay. So after reactions, okay. So I highlight kind of new bond by kind of the green, okay. Yeah, you generate some kind of the bond between this alpha carbon, carbonyl carbon, okay, and then the carbonyl become kind of alcohol, okay. Yeah, because this new compound, okay, so the has the both aldehyde part, okay, so that's the aldehyde part, okay, and those the has the alcohol part, okay, so that's alcohol part, okay. So the product actually kind of we call kind of Aldol, okay. So the aldehyde, okay, so the contribute because Al, okay, ALD, okay, OL means kind of alcohol. That's why this reaction called kind of Aldol reaction, okay. Right. So one clear indication for the Aldol reactions kind of the first thing the either aldehyde ketone, second kind of the sodium hydroxide, okay. So that's casein, okay. So so probably that's the only reaction in this chapter using the sodium hydroxide as base, okay. So other uses the sodium ethoxide or kind of RDA or whatever, okay. So other strong base, okay. So in this case keep in mind, okay. So if you see sodium hydroxide, okay, so 80%, this means kind of Aldol reaction, okay. So right. Here's kind of draw you guys kind of mechanism, okay. So what's going on here? So this mechanism kind of required for this chapter, okay. So Aldol reaction, okay. So we first need depronate kind of R hydrogen, okay. because it's kind of under the basic conditions. Okay, so that's the first step take up kind of the beta alpha hydrogens. Okay, so that's alpha carbon alpha hydrogens. Okay. Right. So then kind of the enolate. Okay. And then enolate will attack kind of the another the aldehyde ketone. Okay. Yeah, attack the carbonyl carbon. Okay. And then you open the CO bond. So I draw this part here. Okay. Draw the lone pairs. Right. And eventually, okay, so this oxygen minus will pick up the hydrogen. Okay. So from kind of the water. Okay, because the first step you generate kind of water. Okay, so and give you final kind of the Aldol product. Okay. Right, so that's it. Okay. So the mechanism actually not hard. Okay, so just keep in mind. Okay, so you need dipronate kind of alpha hydrogen, and then eventually kind of the alpha hydrogen attack carbonyl carbon, and then give you kind of the final product. Okay. Right. So the casing looks like pretty easy, okay, but quite often the student kind of get lost. Okay, so don't know how to draw the product. Okay. So last step actually kind of that's more complicated. Okay. So actually all the step kind of reversible. Okay, all step reversible. Okay, and actually there's one more step. Okay, so the base coming. Okay, pick up this proton. Okay, and then convert to kind of enolate. Okay, that's kind of make the whole thing irreversible. Okay, but so far all the step should be reversible. So far whole step is reversible. Okay, but that's actually kind of not required. That's the middle. No, okay. So the middle carbon. Okay, so that's from here. Okay, so that's there's another bond. Okay, this one is here. Okay, so that's this one. Okay, no hydrogen. Okay, all right. Okay, so that's right. Okay, so there's one more bond on the middle carbon. Okay, yeah, that's right. Okay. Okay, so here's kind of the how do you draw the kind of the Aldol product. Okay, so it looks like easy, but quite often students get kind of the lost. Okay. Right, so here's one example. Okay, so we start with kind of the propanol. Okay, so 3 carbon aldehyde. Okay, so for the most time kind of I will show kind of 2. Okay, so that's kind of 2 aldehyde react with itself. Okay, but sometimes if I didn't show kind of the 2. Okay, so you have to still also understand there are kind of the 2 aldehyde react with itself. Okay, right. So for your beginner. Okay, so if I have understand this is kind of Aldol condensation. Okay, so I will do this first. Okay. Okay. I'll put kind of 2 aldehyde kind of parallel to each other. Okay. Just like this. Okay. So that's the line angle structure for this 2 pentanol. Okay. Right. And then you need to quickly identify what kind of the bond. Okay, build up between them kind of. So what's the first. Okay, find alpha carbon. Okay, from one aldehyde, and then find kind of the carbonyl. Okay, from another aldehyde. Okay. So for example, okay, the top one. Okay, that's your alpha carbon. Okay, and then another one. Okay, you find carbonyl. Okay. So you need build bond between this guy. Okay. Okay. So that's here. Okay. And then molecule, okay, so aldehyde contribute kind of the carbonyl carbon, okay, so that's become kind of alcohol, okay, so this one become alcohol, okay, and then falling kind of very beginning you don't need to draw the pretty one, okay, so you can draw kind of the pretty ugly one, that's fine, okay, so as long as you know what's going on, otherwise all right, just draw the bond, okay, between these two guys, and then this carbonyl carbon become OH group, okay. So that's the final product, okay. So that's how do you draw the kind of Aldol product, okay. But if you want to draw the pretty one, okay, so that's once you get kind of the lot of practice, okay, so that's shouldn't be too hard, okay. Yeah, so that's the relative little bit pretty one, okay, but actually these two are kind of the same thing, okay. Okay, so now you guys take a try, okay, try to draw kind of the product, okay, so with this two acetone, okay, for the Aldol reaction, okay. Yeah. So Aldol reaction can happen between two aldehyde or two kind of two kind of ketone, okay. So two same molecule, okay, react with self, okay, it's pretty much, okay. Yeah, normally speaking, kind of the Aldol reaction happen to kind of the two aldehyde, okay, because aldehyde kind of last their hindrance, okay, so preferred, okay. So but occasionally also happen to kind of two ketone, okay, so so for the ketone you have to use a little bit stronger base, okay, so but it's indeed can work, okay. All right, take a try, okay. So practice, okay. The best way to learn this chapter kind of a lot of practice, okay. All right, okay. So here I will show you again, okay, how to draw the product for Aldol reaction, okay. Aldol reaction, casing, okay, alpha carbon and the nucleophile open the CO double bond of another aldehyde ketone, okay. All right. So here I will draw kind of once you understand this Aldol reaction, okay, the first step you need to do kind of draw the two molecules parallel to each other, okay. And then so we can do this way, you can also do like this way, okay. All right. So here we have two ketones, okay. Quickly find the alpha carbon, okay, from one ketone, okay, and then carbonyl carbon from another ketone, okay. So you want to build bond between these two guys, okay. So and then open the CO double bond, okay. Right. Right. So that's the final product, okay. Okay, so this is the new bond position. And there's a possibility for the kind of the intramolecular kind of Aldol reactions. Okay, so that's actually kind of a pretty interesting topic. Okay. All right, so show you one example. Okay. All right. So we have this diketone. Okay, we apply some kind of sodium hydroxide. Okay. All right, and then we can have kind of Aldol reaction. Okay, because here's kind of the question for you guys, okay? So because that's kind of symmetrical one, so it doesn't matter which one attack which, okay? But probably it's kind of easy to find kind of we assuming kind of left one kind of attack kind of right one, okay? So that's we have carbonyl carbon, okay, here, okay? But there are kind of yeah, 2 alpha carbon, okay? Alpha 1, alpha 2, okay? Okay. So yeah, looks like both attack kind of this carbonyl, okay? So which one will attack kind of right carbonyl, okay? Can anyone type in the chart window alpha 1 or alpha 2? Okay. We have both 1 and 2, okay? Right. So the answer is alpha 1, okay? Alpha 1, okay? The reason for that kind of remember, okay, so in the class, I said kind of reinformation reaction, okay, reinformation reaction, okay. 3 membrane, 5 membrane, and 6 membrane are preferred, okay. So if you have kind of the alpha 1 attack here, okay, so for the intramolecular reaction, actually kind of also not hard, okay. So pretty much you can draw kind of ugly version, okay. So that's in, and then build a bond between these 2 guys, and then this is open, okay, right. So alpha 1 attack here, okay, you generally kind of 6 membrane, okay. 1, 2, 3, 4, 5, 6, okay. Okay, so maybe label you guys kind of know what's going on, okay. So this is 1, 2, 3, 4, 5, 6, okay, 6 membrane, okay. So 1 is the alpha carbon, okay. No, that's wrong, okay. Alpha carbon should be here, okay. This is the wrong structure. 1, 2, 3, 4, 5, 6. So on carbon 6, okay, kind of OH and those the methyl group, okay. So on alpha carbon, okay. So that's why you have to count kind of carbon numbers, okay. And so that's give kind of 6 membrane, okay. So 1, 2, 3, 4, 5, okay. So has nothing, and then on 6 you have kind of the OH and also methyl group, okay. And if alpha carbon 2, okay, attack this the carbonyl, okay. So that's you give kind of actually 4 membrane, okay. So okay. So we do here, okay. So that's here the 3, okay. So that's here the 3, 4. Actually, kind of there's no carbonyl, okay. Two, 3, 4, okay, and then 5, okay. Actually, it's kind of 2 is here. 6. Yeah. 3, 4, 5, 6, okay. 3, 4, 5, 6, okay. So generally kind of the 4 membrane, okay. So 4 membrane kind of extremely unstable, okay. So so that's why kind of alpha carbon 1 attack kind of the 6 carbon, okay. So that's the product, okay. So like I said, kind of the reaction for this chapter can be quite tricky, okay. Right. Let's see, okay. And okay, let's try maybe one more practice, okay. Yeah, like I said, kind of this chapter, okay, we'll do a lot of practice, okay. All right, so now you guys try to work on this reaction, okay. So we have kind of cyclic aldehyde, okay. Okay, So try to draw the kind of product for this here, the starting material, okay. Normally speaking, kind of intermolecular reaction or intramolecular reaction kind of preferred, okay. So because they have kind of low kind of entropy cost, okay, especially at low concentration, okay. So yeah. So that's why I ask you guys kind of if you have kind of say question, or the two functional group, okay, okay, linked by a long carbon chain, okay. So that's normally means kind of intramolecular reaction, okay. All right, take a try for this question, okay. All right, so first thinking, like I said, kind of put the two aldehyde ketone kind of parallel to each other, okay. Find alpha carbon, okay, from one molecule, and then carbonyl carbon from another molecule, okay. So doesn't matter, okay, which one you pick up, okay. So that's here we assuming. Left here, aldehyde can be kind of alpha carbon, right? Aldehyde can be kind of carbonyl carbon, okay. You build bond between these two guys, okay. And then they see the aldehyde become kind of alcohol, okay. So when you were beginning kind of learn how to draw the kind of the Aldol product, okay, may be quite ugly, okay, the bond kind of no straight, okay, whatever, okay, but it doesn't matter, okay. The key thing is kind of you know how to kind of draw the product, okay. Okay. Yeah, that's bond formation positions, okay. All right, okay. So yeah, very beginning, someone still ask kind of So why for the reaction mechanism here, okay? So pretty much kind of just reversible, okay? So you see here, okay, here reversible, here also reversible, okay, and so actually if you want to only generate an Aldol product, okay, so the reaction yield will be pretty low, okay, because the whole reaction reversible, okay. But normally situation kind of people use kind of more vigorous conditions, okay. So like high temperature, long reaction time, okay, stronger base, okay, and then push one more step, okay, and then get kind of we call it Aldol condensation product, also called kind of alpha beta kind of unsaturated ketone or aldehyde, okay. So what happened kind of here, okay, so I kind of draw further one step, okay. So you lose this carbonyl oxygen, okay, or carbonyl OH, okay, and then all those kind of alpha hydrogens, okay. So you lose one water, okay. So and you generate a double bond between these two components, okay. All right, so still new bond formation position. Yeah. So this is we call kind of Aldol condensation, okay. So Aldol condensation product kind of much more stable, okay, because they're kind of CC double bond conjugate kind of oxygen, okay, CO double bond, okay. So that's the product, okay. So So for the mechanism, actually kind of actually also not hard, okay. So we continue based on kind of Aldol product kind of the mechanism, okay. So there's kind of another base, okay, coming in, okay, pick up another beta hydrogens, okay. And then the shared electrons give back to kind of the carbon, okay. So actually from this step, okay, so will become kind of irreversible, okay. And then the electrons, okay, on the lone pair electrons on the alpha carbon, okay, go back, okay, kick off the COOH, okay, and give you kind of the final alpha beta unsaturated kind of the ketone or aldehyde, okay. Yeah, so this one. Yeah. So theoretically speaking, okay, so like I said, kind of the OH group kind of pooling group. Normally you cannot directly kick off the OH group off, okay, but that's the one exception. Okay, the reason for that kind of stability of the final product, very stable. Okay, so so that's also showed you guys here. Okay, so the reaction actually driven by kind of the stability of conjugated carbonyl. Okay, what's that mean? All right. Can you show the product? Okay, sorry. This one? Okay, yeah. Here's kind of for you guys, okay, so how do you decide kind of is ask you kind of only draw the Aldol product or kind of the Aldol condensation product, okay? So just look at conditions, okay? So if we are for example, okay, so I just kind of provide kind of sodium hydroxide, okay? So that means kind of I only want kind of Aldol product, okay? But if I showed kind of heat, okay? Sodium hydroxide with kind of heat design, okay? Or maybe kind of put like the 30 or 20, 100 degree, whatever, okay? So can you show the dehydration? Okay. So just kind of put on the 2 page, okay? I cannot show the 2 things in 1 page again, okay? All right. All right. Okay, so like I said, okay, so if I ask you kind of okay, so I put here, okay. Okay, so if you have this reaction, okay, I ask you kind of NaOH, okay, so that's the Aldol product, okay, Aldol product, okay. Okay, but if I ask you kind of NaOH plus heat, okay, so maybe sometimes I write kind of 100 degrees, 120 degrees, okay, you need to show me kind of dehydration product, okay. So for this example, okay, so the dehydration product, okay, so actually note here, okay, so that's no alpha carbon, okay, so there's no dehydration product. But the others, okay, so you need to show me kind of C double bond between alpha carbon and those carbonyl carbon, okay. Yeah, for example, okay, so okay. So for this question, okay, so if I ask you kind of show NaOH and then with heat, okay. So you need to show me dehydration product, okay, dehydration product, okay, so something like this, okay. Yeah, pretty much lose 1 hydrogen on the alpha carbon and then lose OH group, okay. So build a CC double bond, okay. Yeah. All right, so that's enough for today's class, okay. So we'll continue this chapter and also continue Aldol reaction in the class on Wednesday, okay. So there's still a lot of things need to be covered in the kind of the Aldol reaction. All right, any questions? Oh, you didn't see?
If there's no other questions, I have a question for the post lab 5.
Okay, wait a second. Okay, wait a second. Okay, so
Yeah.
I just want to check anything with is there actual carbon there? Hmm?
For the last exercise that we did together with the 2 6-membered rings,
Okay.
how did you get the extra carbon there? Is there an extra carbon there where the OH is?
No, okay. You mean this one?
Yeah.
This one from here. So that's
okay.
from
Okay.
kind of the carbonyl, okay? Yeah. So that's why I asked you guys kind of very careful about kind of this reaction, okay? So to either get 1 extra carbon, either miss 1 carbon, okay?
Okay, thank you.
Sure. Yeah. So this chapter kind of reaction more complicated kind of here. The very bulky molecule can generate kind of here. So just to be careful, okay. So yeah, when you draw the mechanism, okay. So yeah, very start, okay. So yeah, don't need to be draw perfect one. So yeah, just kind of here the stay root, okay. So yeah, draw ugly one, that's fine, okay. So that's can guarantee you get kind of the right product, okay. If you want to draw the pretty one, okay, quite often lose one carbon or kind of yeah, get too many carbons, okay. Then eventually kind of get the wrong answer, okay.
Can you show the mechanism for the aldol condensation instead of just like rewriting it over your last mechanisms? Can you
Sure.
create a new mechanism?
Yeah. All right. So I will draw you from scratch. Okay. All right. So probably use different color chalk. Okay. So you can know. Okay. All right. All right. So we have kind of here one aldehyde ketone contribute to the carbonyl. Okay. Another contribute kind of here alpha carbon. Okay. So actually kind of we do this. Okay. So this one we do kind of here this one contribute kind of the alpha carbon, okay. Right, so the first kind of OH coming, okay. Pick up here the alpha hydrogen, okay. And you generate kind of enolate. Right, so that's you kind of alpha carbon, okay, and then attack here another aldehyde ketone, okay. Carbonyl carbon, okay. Yeah, so those should be kind of reversible, okay, until you reach kind of condensation stage, okay. All right. So now I put this part on the left, okay. Yeah, you can add lone pairs, okay, but yeah, if you don't want to add it, okay, that's fine, okay. All right, so that's the new bond formation, okay. Right. And then this oxygen minus will pick up the one hydrogen, okay, from solution, okay. So normally from kind of here, okay. So we generate kind of water, okay. So in the first step, okay. So this step, okay, water give back kind of one hydrogen. And then you generate kind of the Aldol product, okay. Yeah, you can add the lone pair electrons on back, okay. Still put the colored one on. All right. Okay, and then last year we done the Aldol, okay. So done Aldol, okay. Whole process kind of reversible, okay. So the Aldol actually kind of has a very small bond, okay. Oh, sorry. Okay. Right. And then if we want to push it further down, okay, so we have to kind of do the condensation, okay. So condensation, okay, so OH come back again, pick up this beta hydrogen, okay. Actually kind of alpha hydrogen, still alpha hydrogen, okay. So the alpha carbon lose two hydrogens, okay. So the first step generate an Aldol, second step to kind of condensation product, okay. And then you give electron back to the center carbon. Here. So from now on, okay, so it will be irreversible. Right. Okay, so that's still the original bond formation. Okay. All right, and then lone pair electrons on the carbon, okay, shift back, okay, give kind of a CC bond, and then meanwhile take off the OH, okay. That's give kind of the Aldol condensation product, okay. Should be no H here, okay, just kind of a single bond, okay. and the new bond at kind of here. So the first round, okay, so you build up kind of here one single bond between alpha carbon and those carbonyl carbon. Second round, you build up kind of here another bond, okay, so let's give kind of here double bond. Yeah, that's the whole process. Yeah, that's the one thing I forgot to mention in the class. Okay, so yeah, for the Aldol condensation. Okay, so you only need to know mechanism until kind of reach Aldol stage. Okay, Aldol stage. Okay, I don't need to know kind of how to do condensation. Okay, so yeah, that's only need to know until here. Okay, so generally kind of Aldol. Okay, and then Aldol condensation kind of you don't need to know. Yeah, condensation you don't need to know how to do it. Okay, so yeah. Right, good, okay. Any other questions? All right, thank you, yeah. All right, let me stop here the recording.